Hello, we continue to explore line graphs and how we can represent data in different situations using such a very powerful visualization tool, line graph. So let's consider a new word problem. Mr. Clark recorded the number of people in his store by the hour between the hours of 5 p.m. and 10 p.m. So it looks like Mr. Clark is a store owner or manager, and he wanted to see how crowded it gets after work between the hours of 5 and 10 in the evening. So as we can see, let's read the table. We see that at 5 p.m., he had 50 people, at 6 p.m., 75, 7 p.m., 125, 200 people later, 100, and finally by 10 p.m., there was nobody in the store. And what he did, he decided to plot this data, right? And we have something 550, right? We have ordered pairs 6, 75, and 7, 125, and so on. So what did he do? What did Mr. Clark do? He created a coordinate plane. Okay, he created a plane where he plotted the time along the x-axis, tick-tock, tick-tock, between the hours of 5 and 10, and he plotted the number of visitors on the vertical axis, on the y-axis, right? We have the number of people visiting the store, and that ranges from 0 to 250. What do we see? What do we see? We see a trend line, right? We see a trend line. The number of people sharply increased by 8 p.m. And we understand why. People come from work, they stop by the store, they pick up certain things for dinner. And then what happened in the second half after 8 p.m., after the hours have peaked, we have a sharp drop in the number of visitors. Look how the line is sloping down sharply all the way to 0 people at 10 p.m. So let's answer some questions about this visualization, right? We're on page 102. In this graph, the x-axis is used for time. That's true, right? Look at this. We have the time. Tick tock, tick tock. Very often you will notice that time, months of the year, years, hours of the day are plotted along the x-axis. Time kind of doesn't change, right? It just keeps on going forward. Now, there are many things that depend on time, such as visitors in a store. What is on the y-axis? We have the number of visitors, number of visitors. That's what the ledger tells us right here, the number of visitors. At what time was there the greatest number of people? That's very easy. At 8 p.m. We can see how the number peaked, right? We take 8 p.m., we go all the way up, and we notice that there were 200 people at 8 p.m., right? Over what time period did the number of people increase? That's what line graphs are so good for. It tells you when we have increases, how steep is the increase, and we know between the hours from 5 to 8 p.m. Over what period of time did the number of people decrease? It's such a beautiful visualization tool between the hours of 8 towards the late evening till 10 p.m. What was the increase in the number of people from 7 to 8? Well, we know that at 7 o'clock we had 125 people, and by 8 o'clock we have 200. So 200 minus 125, the difference is 75 people increase. We have a sharp increase, right? We have a trend that says plus 75 visitors. What was the decrease in the number of people from 8 to 9 p.m.? Notice, let me clean up. Notice the decrease, right? Again, these are so good for us to see the sharp drops. Here we go, right? We went from 200 people at 8 o'clock down to 100 visitors. So it was minus 100 people, right? Or we say dropped 100 visitors. The attendance dropped by 100 visitors. Let's take a look at another graph. Oh, it's so often you will notice the temperatures plotted on line graphs. Again, line graphs are beautiful visualization tools to see the sharp or the slow increases or drops in air temperature. Then he created a line graph. Yes, line graphs are your friends in this case. He created a line graph for data he collected for the highs and the lows over the 10-day period. Remember how I mentioned that typically on the x-axis, you will see on the x-axis, you will often see the time. What do we have? Days from 1 to 10. And what I also said that time always moves forward, right? But what depends on the time? In this case, the temperature depends on the time. So that's why you see for the y-axis, right? Let's label it. This is the y-axis. This is the x-axis. We have the temperature, and it ranges from 0 to 90 degrees Fahrenheit. So we have a trend line. We have a trend line. In yellow, we have the highs, right? The air temperature, the highs go from 73 to 86. So here's your 73, and somewhere here is your 86 degrees Fahrenheit, and this is your 73 degrees Fahrenheit. And similar, the line below are your low temperatures, right? These are your low temps. Low temps. Let's answer some questions about these line graphs. They're so intuitive. We almost know, we almost see the numbers. That's what it's called, to visualize numbers, to visualize data. What values are in the horizontal axis? We have days, right? Days ranging from 0 to 10. What values are in the vertical axis? We have temperatures, measured temperature, measured in Fahrenheit. How does this data change over time? Well, there are many things we can see about this data. We can see that the temperature is rising steadily. It's not dropping. It looks like the air is warming up between days 1 and 10, kind of like in the early spring. Do we see any sharp increases like a heat wave? No. Do we see any sharp temperature drops like in the dead of winter when we sometimes face polar vortex? No, we have a steady rise of temperatures, the highs and the lows, kind of going in sync, right? Look, we have a slight rise and a slight rise and a slight dip, kind of some of this data almost symmetrical, right? The both are going in sync with each other. So again, one more time, the graphs are very helpful for us to notice like changes over time. And we have one more example, number 7. We have more, but I'm going to go through one more. The line graph shows the height in inches for a boy from between the ages of 5 to 12. Again, remember what I said, it is very common for the x-axis to be the timeline, whether it's measured in days or whether it's measured in hours. This one is measured in in years, right, of this boy's age, and it goes from 0 to he's 12 years of age. And it looks like they started measuring his height when he was 5 years old, and they finished measuring when he was 12. And notice, this is how we read the graphs. We go up to our point, and then we go across to see what was the height. So clearly he was not 25, he was probably around 20. The boy started at maybe 27 inches. 27, how do I know? Because it says so, 27 inches tall. What can we say about the age of the boy's height or the change? Well, we do see that between the ages of 5 and 6, the boy grew quite rapidly, right? And then, his growth was pretty steady over time. Like here, he slowed down. And then look at this, over the period between 9 and 11, look at this steep rise. Look at the steep rise. Oh, interesting. Look at the steep rise in his height, right here. This is when he grew the most over the course of 2 years. Again, it's very intuitive for us to see line graphs over time. What was the height when he was 8? Again, this is how we read the line graph. We go all the way, we find 8. We go all the way up until we hit the graph, and then we go all the way across to see what's on the y-axis, and we can tell he was 40 inches, right? He was 40 inches tall. Now, how old was he when he was 35 inches tall? Well, this way we have to go backwards, right? So we find 35. Here is 35. 35 inches. We're going to go until we hit the graph right here. This is the point. And then we're going to drop down to read the boy's age. He was 7 years old. You see how we use the graph. Between which ages did the greatest increase, the sharpest slope, the sharpest incline in height took place? And we noticed that right here, right here. We already talked about this sharp increase. It was sometime between the ages of 9 and 11 years old. I hope you find this helpful and useful, this practice of reading line graphs.